we should do Cybertruck first.
Hey, let's talk about Cybertruck's battery pack. I noticed something special about Cybertruck that makes it perfect as a battery electric vehicle. This is about energy density, but not how people usually talk about it. People usually talk about energy density in terms of mass, how much the battery weighs. This is going to be about space, volume, how much space the battery takes up. Cybertruck's key advantage is energy density, but not just energy density by weight. It's really about energy density by volume. Cybertruck's size and layout creates more room for batteries, for a larger battery pack that holds more energy and allows for different battery chemistries that are less expensive. This creates amazing possibilities for a Cybertruck. This is big. Literally, it's big. Size does matter. Are you ready? Let's go. Right now, Tesla uses nickel cobalt aluminum batteries in the 2170 cylindrical cell format. Their nickel cobalt aluminum batteries have 250 watt-hours per kilogram of energy density. That's called gravimetric, energy density by weight.
It's the company with the best, lightest, most efficient batteries, right?
Energy density by weight matters a lot for vehicles. It matters because the vehicles are moving around. The more weight you have to pull around, the more it matters. It matters a lot less for energy storage, one of Tesla's other businesses, like Power Pack, Mega Pack, but it matters a lot for cars because you got to pull that weight. Having more weight means less efficiency. So energy density by weight matters. If you don't have enough gravimetric energy density by weight, the vehicle weighs too much, and that hurts performance and range. There's another side to energy density, volumetric. How much energy does a given volume of battery hold? How many watt-hours per liter, for example? The Tesla 2170 nickel cobalt aluminum battery carries over 700 watt-hours per liter. The battery pack for the Model 3 is 217 centimeters or 85 inches long, 147 centimeters wide, and 10.5 centimeters deep. That's a total of 303 liters of volume that the battery pack can hold. That's batteries and other things in the battery pack. So it can't really hold 303 liters of batteries. It holds significantly less than that. The Model 3's battery pack is composed of 4 modules. The long modules, there's 4 modules, 2 are longer than the others. The long modules have 50 liters of volume. The shorter modules have about 45 liters of volume, which means that less than 190 liters total for the 4 modules. And keep in mind, that's still batteries and other things in the battery pack. The cells are cylinders, so there's space lost in between the battery cells. And there are other components like channels for cooling. The 2170 cell is roughly 0.024 liters in volume. And there are 4,416 of those battery cells in a Model 3 battery pack, which adds up to 106 liters of the cells. If you look at it another way, the 75 kilowatt hour battery pack, divide that by 710 watt hours per liter, you again get 106 liters. This means Tesla is able to use a little more than half the potential volume to squeeze in the batteries. You can also take height as a given and just look at the area that's available for the battery pack. The 2170 batteries are 70 millimeters tall or 7 centimeters tall, a little over, almost 3 inches tall. That's not going to change, at least not on the Model 3 or Model Y. It may change for Cybertruck, and we'll talk about that later. The 3 and Y have a space for a battery pack that's roughly 85 inches long by 57 inches wide, 217 centimeters by 147 centimeters. 4,416 batteries of the 2170 cylinder take up 19,500 square centimeters of area, or 2/3 of what's available. Cybertruck is bigger. That's great for batteries. There's more available area and volume to hold more batteries. The biggest change is the wheelbase. The Cybertruck is estimated to have a 150-inch wheelbase, or 380 centimeters. Elon did say recently that the vehicle might be a little smaller, so figure 145 inches wheelbase. The Model 3's wheelbase is 113 inches. Model Y is about the same. The Model S and the Model X are a little bit longer at about 116 inches each. So if you figure they're about 115 inches, if Cybertruck's wheelbase ends up being 145 inches or 368 centimeters, That's roughly 30 inches or 76 centimeters longer for the battery pack that it can hold. Cybertruck is also supposed to be 80 inches or 203 centimeters wide, which is 7 inches bigger, 18 centimeters wider than the Model 3. Adding all that length and width gives Cybertruck a lot more room for a much larger battery pack. And that's going to matter. I'm going to explain why next. So now we get into battery chemistry. Tesla recently made a deal with Chinese company CATL to use their lithium iron phosphate battery technology in battery packs for the Tesla Model 3 in China, and they're going to use it for Cybertruck as well. I'm going to show you why. Lithium iron phosphate batteries are an important technology. There's some really big differences between lithium iron phosphate batteries and the more common batteries we see in electric vehicles, whether it's nickel, cobalt, aluminum for Tesla, or we see a lot of nickel, manganese, cobalt batteries talked about in other contexts. Lithium iron phosphate has no nickel, no manganese, and no cobalt, and those minerals are a lot more expensive than iron. So that makes it a lot less expensive to make the batteries. Also, not having cobalt is a big deal because the sourcing of cobalt in the world, a lot of it comes from conflict areas and places that use child labor, and companies try to avoid getting involved in that.
The main feature here is that it is this lithium iron phosphate, which has some major advantages over traditional lithium ion batteries. This one is just enormous compared to this. This standard lithium cell, it's rated for about 1,000 charge-discharge cycles. These age quite quickly. Even in storage over a year, they'll lose their capacity. They don't like being stored in a fully charged state. This is a super stable technology. It lasts estimated about 10 more years, and the charge-discharge cycles, at least 2,000, but potentially they're looking at 5,000 or more.
Lithium iron phosphate batteries cycle better. That means they last longer, more miles. You get more battery life for a lithium iron phosphate battery than a comparable nickel-based battery. They just last longer. It's easier to get to that million-mile battery using lithium iron phosphate. But the energy density is a killer, not just by weight, but even more so by volume. The nickel cobalt aluminum battery used in the Model 3 and Model Y has 247 watt-hours per kilogram. That's 200 kilograms for a 50 kilowatt-hour battery pack. Lithium iron phosphate batteries have roughly 160 watt-hours per kilogram in battery density. And that means the batteries in a 50 kilowatt-hour pack would weigh more than 50% more, adding over 100 kilograms to the battery pack. But this is really about volume. Volume matters, size matters. And volume is a much bigger difference between nickel, cobalt, aluminum, and lithium iron phosphate. The Tesla NCA battery has over 700 watt-hours per liter of energy density by volume. Lithium iron phosphate typically has less than 350 watt-hours per liter, so the same amount of battery energy takes up more than twice the volume, more than twice the space. And this is why Cybertruck matters so much. CATL and Tesla are coming up with innovations that will improve the usage of volume, but with current standards, you would not be able to fit more than maybe a 40 kilowatt-hour battery pack into a Model 3. Where currently they hold 75 kilowatt hours as the largest pack.
There's no point in having modules, really. We just have a pack. We really want to move to no such thing as a module. It's just cells and pack.
With Tesla and CATL working on cell-to-pack technology, eliminating modules, that should really improve both energy density by weight and by volume for the battery packs. But it's not enough to bring lithium iron phosphate to the same energy densities that we see with the nickel-based materials. Right now it's cells in modules in packs. If you take the modules out of the process, the best part is no part, the best process is no process.
The best part is no part. The best process is no process. It weighs nothing, costs nothing.
If you take modules out, those parts are gone, that process is gone. You save weight, and most importantly for lithium iron phosphate, you save volume, you save space. And you make manufacturing easier because there's less steps in the process. Currently, most lithium iron phosphate batteries I've seen are prismatic batteries. It's a different format. It's more like a box than like a cylinder. It's possible that Tesla and CATL will go to a cylindrical format for the lithium iron phosphate batteries, but I think it's more likely they're going to stay with prismatic, these boxes that are larger, and I think that ends up using less volume than the cylindrical cells. A smaller number of prismatic cells may take up less space, they may be easier to assemble and take up less volume, which is critical here. It's also possible that they'll increase the height of the battery to create more volume. The standard lithium iron phosphate prismatic cells I've been seeing are 54 millimeters high, which is shorter than the 2170 70 millimeter cylindrical cell Tesla is using. So it seems likely they will at least increase the prismatic cell to 70 millimeters, and I think they might make it even taller. It's one of the things about Cybertruck is there may be more room vertically to create a larger volume battery pack in that way as well. The single motor rear wheel drive Cybertruck will fill all of that space with a lithium iron phosphate battery pack. I'm predicting 75 to 80 kilowatt hours for a standard range plus version of the single motor model. There probably will be a low budget model that will only have maybe a 50 or 60 kilowatt hour battery pack to get you that minimum 250 miles, but the standard range plus should get over 300 miles of range. With the high cycle life of lithium iron phosphate, getting maybe 5,000 cycles on a 250 or 300 mile battery pack, that means you'll easily exceed the 1 million miles of life, the 1 million mile battery pack life that Tesla's aiming for. For the dual motor all-wheel drive model, which is the one I have on reservation, it should come with the same pack that the lower model standard range plus would have, 75 to 80 kilowatt hours of battery pack, lithium iron phosphate, and over 300 miles of range, and again, 1 million miles of life. I wouldn't be surprised to see Tesla offer some kind of longer range pack for the dual motor Cybertruck with higher density NCA 2170 batteries or some other battery chemistry to get to 100 kilowatt hours and over 400 miles of range. Could happen, I'm not sure, but we'll see. I think it's also possible that Tesla will come to some kind of hybrid arrangement where they will use a combination of lithium iron phosphate cells and nickel, cobalt, aluminum, or some other chemistry. With their advanced battery management skills and the systems that they have in Teslas, it may be that they could optimize how that battery pack works using one type of battery when necessary, the other type of battery at other times, and really extending the life and capacity and performance characteristics of its vehicles. The really fun part will be when we get to the tri-motor with the plaid powertrain and what Elon referred to as the more advanced battery pack.
The tri-motor, a plaid powertrain, the more advanced battery pack.
What is this more advanced battery pack? That is the really big secret that's coming out on Battery Day. We're going to find out, and I'd like to tell you I know what it is, but I would only be speculating. I don't know, and nobody else knows either. Elon knows. A few other people in the company know, but the rest of us, we're just guessing.
Well, anything that goes 0 to 60, what is it, 1.9? Is that the 0 to 60?
That's the base model.
That's...
Maybe it'll use the Maxwell dry cell technology. Maybe it'll use supercapacitors. Maybe it'll use high bars manufacturing techniques. Will it use larger cells or tabless electrodes? I don't know. I think the tabless electrode patent was filed very recently. That might be in a future battery pack. I'm not sure they're going to get to that quickly. And what underlying battery chemistry will the more advanced battery pack use? Will it just be a new version of nickel, cobalt, aluminum? Will it be nickel manganese cobalt 811, which I've seen a lot of research being that's the next step for the NMC batteries? We just don't know. I'm pretty sure they're going to use single crystal materials in the electrodes, and there will be some new updated electrolyte materials, and there will be some new electrolyte chemistry used in the batteries. It looks like this advanced battery pack will have a lot more energy density, and that's going to matter a lot for Cybertruck. The Cybertruck tri-motor should have at least a 150 kilowatt hour battery pack and at least 600 miles of range. With 600 miles of range, if you only get 2,000 cycles out of the battery pack, you're still over 1 million miles. Using lithium iron phosphate batteries is critical for Tesla's future because it keeps battery costs down in multiple ways. First of all, lithium iron phosphate batteries are just less expensive to make on their own. The materials they use are less expensive. But when you're talking about the other batteries that Tesla is using for other applications like Roadster or Plaid Powertrain, this advanced battery pack, by not using nickel, manganese, and cobalt and aluminum, by not using nickel and cobalt in particular in the higher volume models, that means they're creating less demand for those hard to get and expensive minerals in the advanced models. And that'll keep battery costs down for the other batteries they're going to use in the higher end models. Lithium iron phosphate will serve the stationary energy market well because mass and volume don't matter as much for those applications. It also works in low end vehicles that don't need a lot of range. If you're okay with a short range vehicle, and this could matter for within the cities using robo-taxis, 200 miles of range may be plenty for that kind of application. Nickel cobalt aluminum will continue to serve the mid-range vehicles, the Model 3 and Y and the regular models S and X. Plaid powertrain may see that new advanced battery chemistry. I think they've already tested it on the Nürburgring. I see the Plaid Model S with a 120 kilowatt hour battery pack and 500 miles of range. The one thing I'm really puzzled about is Elon claimed that Roadster would have 600 miles of range, and I just don't see how they can squeeze enough battery into that size vehicle to get 600 miles of range.
This is going to have a 200 kilowatt hour battery pack.
Elon said it would have a 200 kilowatt hour battery pack. That's huge in both mass. It's a lot of kilowatt hours. That's a lot of energy, but that means it's going to weigh a lot and it's going to take up a lot of volume unless this advanced battery pack is far more amazing than anybody thinks. 200 kilowatt hours at 300 watt hours per kilogram, which would be better than anything we have now. That would be 1,500 pounds or 670 kilograms. 500 pounds more than the Model 3 pack. And at a really optimistic view on volume, that would be 250 liters, which is more than double the volume of the batteries in the Model 3. So how would you squeeze that much volume and that much weight into a Roadster? That remains to be seen. Maybe Elon's serious about it. As much as I love Elon, as much as I believe in him, I'm not sure he can pull off a 200 kilowatt hour battery pack in Roadster. So just a new thing I've been doing with my videos lately. I'm going to leave you with some clips from the Cybertruck reveal event. I hope you enjoy it, and please come back, please subscribe, please like and everything. Enjoy these clips. Thank you.
We're here to offer a solution. The Cybertruck, the #1 mode of transport for a cyber girl.
So I present to you the Cybertruck. Doesn't look like anything else. The functionality I'm going to describe is within a space that is less than the most popular pickup truck in the United States, the F-150. So we didn't cheat in either width, height, or length. And we're able to achieve much greater capability in the same dimensions, same weight. Yeah. Really wind up. Nail it. Yeah. You want a truck that's really tough, not fake tough? It is literally bulletproof to a 9mm handgun. That's how strong the skin is. So it's ultra hard, cold rolled stainless steel alloy that we've developed. We're going to be using the same alloy in the Starship rocket and in the Cybertruck. Yeah. Sure? Yeah. Oh my God. Well, maybe that was a little too hard. In addition, the car has an adaptive air suspension. It's literally built, adaptive air suspension. So this will come standard on all the cars. I think this is actually a very important design element because if you have if every truck has the ability to adjust the ride height, so you can go very low or very high, so you can be efficient on the highway, and you can also go off-roading. It's going to have the highest clearance of any production truck. So we're going to have about a 16-inch clearance. And you can adjust this on the fly. So it's adaptive damping and adaptive ride height. These are actually extremely important for a truck. Because trucks, when you only drive them, they're either too cushy or they're too hard. You need it to be able to adjust dynamically depending upon what the load is. If you've got a lot of people on board, if you've got a full bed in the back, it's got to adjust accordingly. The rear is 100 cubic feet. 6.5 foot length, bed length, up to 3,500 pounds of payload. See which one can pull which. Let's do the tug of war video. It was uphill. How does this compare to a Porsche 911? Okay, we're going to give the Porsche a little bit of a head start. Yeah, this is a current edition Porsche. And this is the actual truck. This is not CGI. In terms of off-road performance, it's going to have the best angular approach angle, best clearance heights, best departure angle. For people that are really going off-road, this is going to be great. You could basically do the Baja Rally in this thing. We have 3 ranges. It has onboard outlets for 110 and 220 volts. So you don't need a generator. The truck literally is your generator. And as a little plus, because it's got an air suspension, we can tap off the air suspension, so you have a pneumatic source. So you have you need an onboard air compressor. But it's gonna. So that's the price without any incentives. That's just like the price without any incentives. But the actual economics are even better than that because the cost of electricity is much less than the cost of gasoline. We also made an ATV, so well, let's bring it out. So you can see the truck. This is what I mean by the adaptive air suspension. Yeah, nice work, by the way. So the adaptive air suspension, you can drop real low, and you go high on the other side. We call this load mode. So you got load mode, you got a built-in ramp. So you can take an ATV or dirt bike, whatever you want, and load it on the back. Yes. Oh, and it's currently plugged in and charging. Yeah. Feel like the car is adjusting itself? Yes, that's adjusting. So you can go like real tight on the freeway, and you can go way high off-roading. Yeah. All right. Thank you.